shouldn't.
So good.
I shouldn't have started recording this meeting yet. Crud.
So tired.
Does anybody have the link to watch this online handy?
Nope.
Dang. Because I don't either. And Annalie can't make it, and she wants.
Do a lot of people watch it later? I guess can you track
Watch it later? I don't know. Watch it during? No, I think this is the first time that it's actually been important. It is way too much trouble to. Oh man. I gotta sign in.
Get all this info. Get all.
To Annalie. Minor changes. Okay. Oh yeah, nice. I haven't started sharing my screen yet, so they've just been hearing me complain about how people can see my password and stuff. But nobody can actually see it.
Yeah.
Yes,
That's happening.
That's doing a thing.
Okay. So, does anybody want to work on activities? I don't. Oh, you guys are here to work on activities, not to review for the exam.
I mean, I'm kind of here to do both. But
Well, I mean, hopefully they go together, but primary objective today is to study for the exam. This is officially an exam review and not one of my normal sessions.
yeah, I can do both. Multitask.
I'm just here to do activities and listening.
Okay, well,
I'm here to review for the exam.
I'm IT where everything just kind of works.
Huh?
IT where everything just sort of kind of works.
The internet kind of works sometimes.
oh, is anybody else having internet issues?
I was having some earlier whilst playing Metro.
Oh, yeah, I always have.
Be quiet, you.
Video game issues. What did I get wrong here? Oh yeah, this. It's just being a good one, right? Or in this case. Yeah, -1.
Okay. 10 and 11 will probably be 10 and 10 continued will probably be the bulk of the exam, I think. They'll be the hard stuff on the exam at least. Seems like it's all trigs.
This is completed.
Do the second half then.
Wait. Oh wait, no, it's not. Wait.
Oh.
Never
What am I
mind.
doing?
Is it? I don't remember.
I don't know.
No, it is. It is. These are things that are wrong. I guess I just don't know the right.
Okay, so we're going to check this for you.
Yeah, I think these are wrong. Because maybe I guessed, or maybe I didn't. But I don't.
That,
I think I did just do it.
this.
Okay. Yeah. And then this was the original.
Okay. So, kind of obnoxious to wait. I want to see if Annalie actually gets on here. Because she actually wants to review for the exam. Emily.
Oh, yeah, I'm here to review. It looks like I'm done. So, with activities maybe, so. Review time.
Host me. That's it.
So there's 3 more weeks left, right?
Ish,
After this
yeah.
week? You know, there's 3 more weeks left.
I have absolutely no idea. Just I was kind of floating around
As long as I pass, it's okay.
basically.
I would like to have at least
I would
that
like
was
to
terrible.
actually take 159 next year.
159?
Yeah, whatever the hell.
I don't. This is the
I
end.
forget
This
the
is
numbers.
the end of the road for me. So
Everyone else is jealous.
hey, choose your major. Oh, that's. I'm sorry. Why would you choose that?
Because it's interesting.
That
I guess for now, just go ahead and work on those, and
It's a very.
I'll help you guys out.
Okay.
Have you all finished the practice test? Have you all started the practice test? Ha ha!
I'm not sure.
Haha! It's not. Annalie is not here, but Akoni is here online, which is not what I expected.
What o'clock?
Not what you want?
Well, I mean, because I just sent her. I just sent her an email. Akoni, send me a message in the chat if you can hear me.
Okay.
Oh, nice. Cool. Awesome.
He's back.
Hey, what's up?
For the first time ever, we have an online person.
Yeah.
What's an online person?
Akoni is our online person.
Listening in on.
Just put something in the chat whenever you have a question. Or if you have a question right now. Because nobody else currently has a question.
Who's Tony?
Akoni is one of the
He
students in
sometimes
class.
comes.
He's there sometimes.
Yeah, I thought that was Coney Island or somebody else you were talking about.
An island is
Coney
one.
Island is on.
That doesn't-
Impressive.
It could be his last name. Island.
Cosine.
First name Coney, last
Main
name
cosine is opposite.
Island. For consonants, for Constantine.
There's a lot going.
Cosine.
There you go. You see how we can complicate this very quickly? Are we gonna need a calculator for this pre-test? No, of course not.
Not for the practice exam, probably not for the exam, I heard.
agree.
That. Would you also like 10?
Sure.
Here's also 10. So I said that this was supposed to be primarily an exam review.
Yeah.
Turns out all the people who actually want to study for the exam are online, and everybody here just wants to do activities.
I'm good at exam review.
Okay, well, where's your practice test then?
What?
How's your practice
Right
test?
here.
Oh, it's in your lab.
How many people do we have online?
One currently, Annalie is trying.
Well, you can get started because you can always email the document that you used today, right?
Documents tend to be nonsensical without the video, without the audio to go with them, though.
Yeah.
Let's do later.
Did you just hear that? He's calling your sessions nonsensical.
I mean, if you just have what I write on the board, they
It
are
kinda
a little
looks
bit
like-
nonsensical.
Oh, so you agree with that determination? Okay.
It kind of just
And
looks
this-
like him writing and then erasing everything and then writing something
Oh, yeah,
unrelated
it is.
and then erasing everything.
Yeah, I would have, yeah.
I personally would be horribly confused just looking at that.
So, oh, here we go again about this, I have to leave by 2 o'clock.
Okay, well,
It's crazy, isn't
let's get started then.
What time is this session going from, time to time?
From now until 3.
Okay, and the other question is, are you having tutoring hours later today?
No.
Okay, all right, I guess we should just
So,
jump on top, man.
do you want to study for the exam or do you just want to do your activity time? Okay, cool! Yeah! Somebody who wants to study. Perfect.
Can I do both?
Well, you can try to do both, but
Of course I'm gonna do both.
if you want to do both, if you want to study for the exam, you should be looking at your study.
I am, I have it in front of me. I'm gonna simultaneously both.
Okay.
I've got like so many documents, you know, it's like, where did this thing come from? Oh, that's another thing. And my phone died out. I need electricity.
You don't need your phone for this review.
No, for, just to be in general.
My tendency to be very weird, because I
That's like what I tried to do and I got it on book. It looks right, you know, so. I think that's fair.
Signing now. Everybody's signing now.
Trying to make sense of this.
You know, my phone died out, my iPad died out. We didn't have phones that, like, when you walked or moved, the phone just regenerated from kinetic power.
You would think so, but that would be. Okay,
That'd be
has
difficult
everybody
with all
started
the
the practice
costs.
test?
No.
Brian, have you started the practice
No, I
test?
just haven't completed one. That's-
Okay.
But I won't look at the answers. This is Xavier's, but I'm using it because I don't have.
Oh, Lord, I just found a magical 20 hidden in my
I can work on
backpack.
any problem.
I feel so rich now.
Please try to do a couple of problems on the practice test. That's what it's for. My expectation was that you guys would have something done and questions about it rather than, how do I do this practice exam? Because it's your exam, just, it's gonna change it a little
Is
bit.
it, yeah, of course. Besides just doing the problems, can we talk about the concepts of it? Like, you know, like,
The concept on
I'm
it
having a
appears
hard
to be
time
trig, which is,
well, I'm sure you'll talk about the concepts as we go along. What am I even saying? Never mind. Forget it.
okay, well, we can write out the things that will be on the exam. First thing that will be on the exam, unit circle. If you don't know the unit circle by now, you have some work to do before Friday. You really have to know the unit circle. And I don't mind talking about the unit circle the whole time that we're here, because if you don't get it, then it will help a lot for you to get it by the end of today, but it would be best if you guys all sort of understand that by now.
My big one's I have to keep practicing calculating what pi is, you know, like I know pi is 180 and pi divided by 2 is 90, and pi divided by 4 is 45, and pi divided by 3 is 60, right?
So you pretty much,
So you know it all.
And then 2 pi divided by 4
why would you say 2 pi divided by 4?
is really just pi divided by 2, which is really just 90 degrees.
Yeah.
Okay, so those are the ones that I gotta wrap my brain around. You know, maybe I didn't have my caffeine this morning, but when Dr. Zazi was like running through everything, I was like, I feel like I'm 2 steps behind him in my brain. Oh wait, orange pen. The orange pen got stuck at my desk station. Who needs this?
Here,
Never mind. Here, we're giving it back.
There's a different pattern.
Okay. Yeah, you guys can sign in with whatever color. It doesn't have to be.
Yeah, I thought about it.
Does anybody have any questions over these things so far?
Yeah, can you go over the unit circle?
Yep. Let's do the unit circle. Okay. I'll be a little bit fancy. I'm assuming that if we go over the unit circle, it means I should also go over radians. Radians in general, right?
Yes.
Yeah. Nobody likes radians at first. So, you know sort of what degrees are. You know angles and degrees. Radians are much easier to visualize. If I give you 540 degrees, do you know where that is in the circle?
Yes.
Okay, where?
It's
You did a thing with your hand, but I don't know where
you go 360,
Okay, and
and then keep going until you get to 540.
where's 540 though?
It's before the next completion, so it's in. It looks like the 4th quadrant. Okay.
540 is here? It's in here somewhere, is that what you're saying?
Probably. I have to.
It's 270 times.
Okay,
Is it 270 plus 360?
exactly. Degrees are hard. 540 is here. Ah! That wasn't supposed to happen.
Okay.
This
so
is 540. 540 is the same thing as 180. The reason I like
Is there a
radians...
quick way to figure that out?
Yeah, 270
540.
times. 270 is 3 little corners. 270 times 2 is 6 little like things. 1, 2, 3, 4, 5, 6.
So, I like radians because if you give me pi, I know you mean this distance. And then if you give me any multiple of pi, I know it's either here or here, and I can just count it out. It's easy.
Yeah.
Same thing with anything like pi over 4, pi over 6. Pi over 6 is here.
It's a 30-degree angle.
Yeah, this is not 30 degrees. Well, I mean, it is 30 degrees, but it's pi over 6 radians. I think it's easier. Because now, if you have 37 pi over 6, you sort of know where that is because you can count 37 of those.
And then
Whereas-
you divide that number by 6.
You take
Oh,
this
wait, never
distance
mind.
and you go around.
Never mind, you take 30
times.
degrees and you make it 37 times. Got it.
Yeah. Do you guys all know what the cosine of pi over 6 is?
3 over 2. Square root of 3 over 2.
Let's go with yeses and nos for now. I mean, good, but if you say it, now everybody knows it,
Sure
and I
they
want to
will.
make sure that everybody knows it first time, which is fine. No, it's not a big deal.
So you right, yes. I do know. What if you're wrong and you say yes?
Well, I'm screwed.
The person who thought the longest will have to give the answer. How about cosine of pi over 4?
Yes.
Yeah.
Does everybody know what pi over 4 is?
Yes.
Okay.
It's 45 degrees.
Okay. As long as you know that, you should be able to more or less figure out how radians and degrees work.
Adjacent over hypotenuse.
Don't do adjacent over hypotenuse.
No.
Because on the unit circle, you need to be super careful.
Okay, so on
Because
the unit circles, we
on
don't
the unit
use COT and all that. So
On
it's
the
just
unit-
square root over, is it square root over 2?
Let's say you have this. On the unit circle, technically, that means that you have an angle like this. You guys should just know that the cosine is the x value, and the sine is the y value. You guys need to just know that. You shouldn't have to use SOHCAHTOA on the unit circle. It should be easier than that. If you're using SOHCAHTOA on the unit circle,
Is that me?
No, it's probably over there, can't get to it too bad.
if you're using SOHCAHTOA on the unit circle, you're wasting a lot of time. You're wasting a lot of time. Especially because h is 1 everywhere. So everything will just be obvious in any case. Just know,
Does SOHCAHTOA still apply to this unit circle? Like the theory of it?
yeah, but you have to make sure you're using the right triangles, the correct triangles. I will occasionally do this as my reference triangle. Suddenly SOHCAHTOA flips and I'm getting everything wrong. So don't.
Well, can you do the
That's why-
reference triangle the opposite way then?
Well, yes, but you have to make sure that you
You won't
always
get
get
it
your
wrong.
reference triangle correct.
Okay. Well, the reference triangle has to be within the circle that,
The one I drew was. So
Yeah.
don't do a reference triangle unless you have to. Don't do SOHCAHTOA unless you have to. On the unit circle, if you have an angle and he just asks you the sine or cosine of the angle, just know it's the x or y value there. What's the cosine of 2 pi over 3, Christopher?
2 pi over 3.
Okay, well, where is that first?
It's
That's
a
a
60-degree triangle, I know that. And
Okay, well,
then,
where is 2 pi over 3?
it is 120
Where is that?
in the second quadrant.
In the second quadrant here.
Yeah, right there.
So what is this, what did I say, cosine or sine?
You said cosine, I believe.
Give me both. What are the sine and cosine of 2 pi over 3?
Okay. Well, I don't know.
The sine is the y value.
Oh, that's right. Yeah, the sine is the y value. That's 1. Is it 1?
This
Wait,
is
no.
this is one.
It's draw a line across to the y-axis so I can see. It looks like.
Okay, well, there's that line.
Yeah, I'm trying to remember. It's this line.
Right,
So
but
the
how long
distance
is
of
that
this
line? This is the thing. You should know these. These should not require any thought.
This gives me
Okay.
something. It's a,
Sorry. It's cool. I have a job interview, and by rights I should have negative money in my account.
I hope you get a job.
Good luck.
Hope you do.
shoot. And I had these memorized yesterday. Isn't it like square root of something?
Yes.
Square root,
The- okay.
square root of 2 over 3.
So this sine. Yes, you pointed to the correct triangle. If you replace A with 1, those are the answers, but you shouldn't have to use that. You should know the sine and cosine of this angle. You should know them for this angle, for this angle. Because you should know them for pi over 6, pi over 4, pi over 3. And then any multiple of those, you should be fine with.
Wait, are those all 30 and 45?
Yes. Yes. That's why we use them.
How does it work with multiples of them?
Is the answer the same?
If you, the answer's not the same, you have to find the right spot on the unit circle. Let's say, I don't know, 5 pi over 6. Where's 5 pi over 6? Where's pi over 6?
30 degrees. That's what you have right there in black.
So 5 pi over 6 would be 1, 2, 3, 4, 5. Oh, it's not to scale because I'm bad at drawing.
That's not a problem. Okay, so
It ends up being
that's what it is.
this one, where this angle is pi over 6. Why is it weird? So the sine of pi over 6 and the sine of 5 pi over 6 are the same. But the cosines are opposite. The cosine of 5 pi over 6 is negative. Alternatively, you could just memorize the sine and cosine of pi over 6, pi over 4, pi over 3. If you memorize these three, and then you know sine and cosine are both positive here. Sine is positive, cosine is negative here, right? Because cosine is the x value. So if x is negative, cosine is negative. So then, which ones are positive and negative in the third quadrant? Road. They're both negative.
What is the sine and cosine for pi over 6? Is 30 degrees?
What's this triangle say?
Is it this one or this one?
Yeah, which is which?
Does that depend on which quadrant it is? It's always the same. Is the long side always sine?
No, the long side is not always sine. I mean, oh
So it depends on the quadrant?
my god. It doesn't depend on the quadrant.
Well, pi over 6, it would be the long side is cosine, but if it was like 5 pi over 6, is that the way?
Just say that again.
Pi over 6 is on top of it, so the long side's the cosine,
Yes.
but how you had it,
So this is cosine, and this is sine.
and 4 pi over 6, it would be the other way.
4 pi over 6 would be here. Is that where you're trying to be?
So then it's
Here, this is the cosine. This is the sine.
What is pi over 4? What angle is that? 45?
Okay, so
Pi over-
my question is one more level beyond what we're just talking about 3 times here. I'm trying to remember what on the 45 angle, it's something something square root of 2 over something on a 45 degree. And then it's is it always this? Always this?
Well, is what always this?
Both the legs of the triangle, 45 degree angled triangles, is always the same, and it's hypotenuse times square root of 2 over 2.
Yeah.
Is that correct?
Yes.
What's the one for the 30, 60, 90?
It's well, think about it this way. This angle, let's call it 30 degrees. What's the sine of 30?
X value. Excuse me, the Y.
You should know the sine of 30
Sine
degrees.
is opposite over hypotenuse.
Let's call this H. The theorem that we use all the time is that on a 30, 60, 90 triangle, the shortest side is half the hypotenuse. And then the second leg is 3/2 times the hypotenuse. So on the unit circle, h is 1.
Yeah.
So the sine of 30 degrees
1/2.
is 1/2. And the cosine of 30 degrees is 3/2. But you need to know these. You need to memorize the
That's-
sine and cosine.
That's what I needed to look at so I can
Okay.
memorize it now.
Okay, good.
That's what I was asking for. Because I keep having, in my notes, it's just numbers. I don't have the what you just wrote.
What do you do with the lambs on the 180 axis? 180? Like if you have the.
What's the y value here?
Zero?
Okay, what's the x value?
Zero?
The x value is not 0. The x
It's
value
1, -1.
It's a unit circle. That means that this is 1. This is 1. This distance. So this is 1 to the left, which is -1. So your x value
So it
is
says
-1.
sine 2 pi. What's the answer?
Sine of 2 pi. Well, okay, you tell me. Where's 2 pi in the unit circle?
0, 1.
0, 1. That would be here. Is that what you meant to say?
Oh, no, 1, 0.
1, 0. It's here. Okay. So what's the sign of that? The sign is the y value.
Zero.
0. Sine of 2 pi is 0.
On this one, is that square root of 3 divided by 2, and then both of those together times h at the bottom of this triangle?
This is the same as
H square root of
h
3
root
divided by 2?
2. Yeah, it's all the same. Do you guys need me to just write down the sines and cosines of pi over 6, pi over 4, pi over 3? You guys again.
Yeah, I would, if you can write them fast, I wouldn't mind. I don't care. If it's not too tedious.
Well, okay. Let me tell you something. So right now.
Oh wait, you mean this? I already have these things.
No, I don't mean that. I mean the actual values of the sine and cosine of pi over 6, pi over 4, and pi over 3. This is pi over 6. This.
The sine of pi over 6 is 1/2.
The sine of pi over 6 is 1/2. Yes.
Yep. Yep.
Because it's just this triangle where h is 1.
I'm speaking, as you know, in terms of the unit circle.
So then,
And then it's the cosine of pi over 6, because that's pi over 6 is the radians, correct? Okay, so the cosine of the radian pi over 6 is square root of 3 over 2 because the h is 1. Okay, can we just write all those out really quick? Or I think that'd be really useful because if you don't know that basic understanding, everything else is just going to be all screwed up. That's my opinion. I think it's worth the effort to do it.
okay.
I think I might have a chart here.
Hey, look, you have a chart here
So let's just fill in the chart.
for all of these values.
No, I wouldn't push that. That's just way too crazy. I could find out the rest of. Actually, I can find out this if you want.
I mean, it should be easy. It should be easy to do all of those because, look, you've got 0, you've got 30. You don't have 45. Write down square root of
square root of 2 over 2.
yes, that. Write down that for the sine and cosine of 45 degrees.
Yeah.
I have a question. So cosine and secant are just the reciprocal of each other, right? Okay.
And then the cosine of a 60 degree, it's the reverse. It'd be 1/2. I bet. I bet you it's just the reverse.
really only have that left?
Yes.
Well, you should study for the exam with us for a bit then. Okay,
I'm leaving.
So-
Oh, okay. I have 150 bucks.
does anybody else have a 150 class?
Here. See, now you can use it. And it helped a lot.
Wait, how does this look? This is
This is one
pi
China.
over 6. So I don't draw it.
How does that consider cosine?
The sine is 1/2,
For
right?
this one?
So the sine is 1/2
Okay.
for pi over 6, pi over 3. The sine is 1/2 for pi over 3.
Why is the sine 1/2?
And we just have to figure out if it's a negative or positive.
Okay.
Because
so,
like if I take this, so like in this example, it would be negative 1/2. In this example. Oh, no. Well, that's fine. No, draw anyone. I'll tell you how it is. It doesn't matter.
I want to do pi over 3.
Okay, pi over 3.
That's the triangle for pi over 3.
Okay, perfect. There's your 60 degrees. Mm-hmm.
You just told me that the sine of this is 1/2.
No. So,
That's a horrible
yeah. Yeah, now it's 1/2. Now it's accurate.
Like this.
Mm-hmm.
The sine of this?
This one.
The sine of this is not 1/2.
Okay.
Yeah, like those, or, yeah, like those.
This is the y value, so it's from that, where that red x is all the way up to the circle. So that's the sine of pi over 6.
This is 60 degrees.
Right, pi over 6, right?
So the
Excuse me.
opposite on the 30, 60, 90 triangle, the opposite from 60 is not 1/2. What's the opposite?
It's a square root of 3 over 2. And then the cosine, which is the x value, is 1/2. The cosine.
Wait,
The cosine is 1/2.
What's tangent?
Sine over cosine.
And then for 90 degrees, let's see. 90-degree triangle, the cosine, which is the x value, is 1, right? Oh,
So you're
how am I
over here.
hearing?
This is where x is 1. So your 90-degree triangle goes over here somewhere? So what we're doing is
No, the answer is no.
the triangle shrinks kind of as we go up and around like this.
Mhm.
So what's the triangle you draw if you're at pi over 2?
Oh,
90 degrees.
it's a straight line. From the origin,
Straight line up.
yeah, straight line.
It's not really a triangle. Exactly.
So let's see, the cosine is 0 and the sine is 1, right?
Yes.
Okay. Then what's the triangle that looks like this from that point you just drew up the top to the y green point? Would that be considered to be a 90-degree angle too? You know what I'm saying? See where the green,
We don't care about that triangle right
oh, we don't?
now. No.
Oh,
That,
okay.
that triangle has a hypotenuse of 2. All the triangles we want to deal with have hypotenuse of length 1. Or sorry, it has hypotenuse of this length, which is not 2. It's something else.
It's something else. Okay, so we're not worried about that one.
Right.
Okay, makes sense. Forget about that. It's another course exam topic going forward. All right. So keep testing me. I like this.
Okay. No.
Looks like a 45.
Yeah, let's call that. Let's call that 5 pi over 4.
Yeah, I see that. 5 pi over 4. So the cosine is negative square root of 2 over 2. And the sine, which is the y value, is the same, negative 2 over 2. So that point right there where the arrow is, would that point be considered negative 2 over 2, comma, negative 2 over 2?
Square root.
See, that's what I'm saying.
It's
Negative
not-
square, okay, I'm thinking in my head, my brain's going really fast, sorry about that. But is that considered the point right there? That is the point. Okay,
Those are the coordinates of this point.
Those are the coordinates of that point. Okay, super. Okay, that
Wait,
makes
did you
sense.
say tangent was sine over cosine or cosine over sine?
Sine over cosine. Tangent is sine over cosine.
And if it's negative 1 over 0, is that undefined?
Yes.
What about 0 over negative
What's 0 over a?
1?
0 over 7 is 1. 0. 0 over anything that's not 0 is 0.
Okay, I like this test, this is fun. It's getting fun now. Okay,
We haven't started doing identities
okay, let's move to identities, because this is too much fun now, because I'm starting
yet. You're
to.
starting to understand it.
Yeah, and I just need to make sure I say square root of 2 over 2.
Well,
So I don't
you
get
make
like,
sure you write it.
oh, I did, and by the way, I wrote that exact point, and I showed that the angle on that is 5 pi over 4. And
Oh,
I'm,
good.
so I'm beginning to reverse it now, when you say something like 6 pi over, I don't know, 5, that should be bad. It's just too hard. 6 pi over 3,
4 or 6.
yeah, 6 pi over 3, then I know that that is actually 360 degrees.
Yes, good.
I came up with an example and I just figured it out. That was a little too easy, wasn't
Wait, how do I divide fractions? If it's square root of 3 over 2 divided by negative 1, then multiply square root of 3 divided by 0?
Yes. The way you divide fractions is that you multiply by the
it? Flip and multiply. I think that's the most fun thing ever.
So it would be 2 square root 3.
Makes life easy.
Yes.
Would I cancel these out? 2 square root 3 over 3 square root 3?
Well, you can simplify, yeah.
So the final answer would just be square root 3.
Yes. Unless it's negative, I don't know where you are. Make sure you don't forget your negative sign. 30 degrees. Do you want to talk about these? Oh, no, you know what? We'll talk about the unit circle one more time. It's a horrible circle, but just for the sake of. Okay. On activity 10, there's a question. You know what? Whatever. Dude. It says sine of what?
I over 2 minus b.
Pi over 2 minus phi.
Yes.
That's pi over 2. Minus phi.
I understand that much.
Okay. You are given this triangle.
I'm confused about that part. Alright.
So you're given this triangle. Not to scale. That drawing things to scale. Okay. What's opposite phi?
The thing that you just drew an arrow to.
X squared minus 1.
What's opposite phi?
X squared minus 1.
This distance is x squared minus 1. so far?
Yes.
It's this distance.
My best guess.
Your best guess. Sure, give me your best.
X squared plus 1.
You do know, it's given to you. It's x squared plus 1, you're right. Oh, wait, no, hang on.
I was gonna say, that looks reversed.
Oh, no, he gave you the hypotenuse. Why did he do that?
Are we doing number 2?
Just a minute.
Are we doing number 2?
No, we're doing something from activity 10.
Is it on the test?
It's not on the practice exam.
Is it on the test?
Probably not.
Okay.
So, okay. Christopher's right. That's the hypotenuse. So, that's the hypotenuse.
Yeah, right there.
How do you find this length?
Pythagorean theorem?
Pythagorean theorem.
Alright. I thought it was supposed to be a unit circle. That's why I was so lost.
Okay, question. Tangent of 7 pi over 2, which is 630 degrees, tangent is 0 because it goes around once and then, yeah. How did you do that so fast in your head? Because you knew that
4 pi over 2. 3 more pi over 2. 7 pi over 2. That's why I like radians. I have no idea what 630 degrees is. I have no idea.
But you know that pi over 2 is 90, and you said 7 of them, and you know 90 around once is 4 pi's over 2.
See, I don't even know. I mean, I sort of know what 90 is. But I
Okay,
don't think
so,
about
but
it.
we came to the same conclusion, that's the 630 degree mark, or 7 pi divided by 2 radian.
Okay.
What is the tangent of this? Is it 0?
What is tangent? Tangents. Tell me how to find the tangent
Tangent is opposite over adjacent.
without using those terms.
Yeah, so that's what I don't know how to find.
Tangent is sine over cosine.
Oh, sine over cosine. Sine over cosine. So, -1 divided by 0 is -1.
-1 divided by 0.
-1 divided by 0.
What is anything divided by 0?
Oh, undefined.
There you go.
Undefined, right?
You are never allowed to divide by 0.
-1 divided by 0 equals undefined. Okay, and then the secant. Secant is with cosine. It's 1 divided by cosine.
Yes.
1 divided by cosine. 1 divided by 0 is undefined again.
Yes.
Okay, and we're still doing the 60 degrees. I should point out I'm in activity 9. Okay, cosecant.
Is 4 over 9.
1 over.
Oh, wait, secant.
Y is 4 over 9.
Okay, how do I know what kind of angle this is? It looks like a 36.
Doesn't matter.
It doesn't?
It doesn't. The sine of theta is the y value. The cosine of theta is the x value.
So how do I find this?
You have a right triangle. You have 2 of the sides.
Is it a right triangle?
Of course it's a right triangle.
How do you know?
Because it's always a right triangle.
What do you mean?
I mean, the only reason we draw this line here, this line for y, is because it makes a right angle. That's the only reason we draw it. We don't draw a circle like this.
I mean, couldn't it be 36 feet also?
Well, it could be, but it's
Does it just not look like it?
well, it actually can't be. It can't be because y is 4/9. If y is 1/2, then this would be a 30, 60, 90 triangle. Y has to be 1/2 or √3/2. Otherwise, it's not 30, 60, 90. So
Shouldn't it also have to be square root 2 over 2? For 45 degree triangle?
it's not that either.
So it doesn't
It's just a right triangle. You know how to find all the sides in a right triangle.
Oh, Pythagorean.
Yes.
Okay, I thought you meant it was a 45 degree triangle.
I feel like my anxiety level's decreasing. Okay, this is kind of fun. I have some really good stuff over here. And I'm doing this right.
Oh, yeah, Oconio's gone. This is a horrible software. Oh, crap, I got recorded saying that.
I think it would pop up with like messaging or something.
Yeah, I didn't miss that, did I?
I don't think so.
I didn't see anything.
I couldn't
And-
all the time.
And now he's gone, so I can't answer his question. Although Professor Zazzi did answer his question today during class, which he missed.
That's awkward.
Oh, I think I just made this really complicated.
Made what really complicated?
Okay. This one right here.
Okay, first, it's a right triangle. Right?
Yes.
Okay.
It's right there. There's the right triangle.
Sure. Okay.
It is. I don't know if it's on the unit circle. It doesn't specify that. Oh, hello. It does specify that.
It is a unit circle. Also, it's a right triangle, so this squared plus this squared equals this squared. And that will happen to be 1 if you decide to do that calculation.
Can this be further simplified?
Oh, no. Okay, no.
That's what I thought.
Don't use a calculator.
Who has a calculator out?
I'm just trying to figure out the rule.
Okay.
What do you need to figure out the rules?
This isn't fully simplified.
I don't care. I don't think Professor Zazzi cares either. Professor Zazzi and I both write this all the time. This is exactly what we write. Because we don't want to go to the trouble to simplify it and rationalize it in our draft.
Okay.
What is it? What's a period? What does it mean by the period of a given function?
Were you in class today? Were you in class Monday?
I don't remember.
You don't remember? Well, that's not a good way. Okay, so if you have sine of ax instead of just sine of x, you're going to squeeze your function. So sine of x has period, what? Can you tell me? Sine of x has period what? What does sine of x look like? Sine of x has period what? 2 pi. This is what Professor Zazzi did during class Monday, I guess. You take this distance, because after this, you just get to repeat exactly the same over again. So 2 pi is the period. Cosine x also has period too.
So when it's asking for the period, it's just telling me to drop it down. Like, if it says sine 4 pi x, the answer 4 pi.
No. What?
Is it 4 pi squared.
This is the same as sine of 1x,
Okay, so
and the period is 2 pi.
this is 4 pi squared.
Why would it be 4 pi squared?
Because it's 2 pi.
Okay, so
Because it's 2 pi times 4 pi.
sine of x has period 2 pi.
So sine of 4 pi x.
It has period this. Sine of ax has period 2 pi over a.
So it's 2.
Maybe
Sine of 4 pi x.
2 pi over 4 pi. What is 2 pi over 4 pi? Not 2.
Doesn't it cancel out the pi?
What is 2 pi over 4 pi?
1 half.
I'm pretty sure
What about with like tangent, cosine?
Cosine has the same period as sine because they look pretty much the same, right? Cosine, it just looks like this. Except I'm a horrible artist. Wow, that was terrible. Let me try that again.
Is this inverted?
It's not inverted. And then it keeps going like this.
It's shifted?
It's shifted.
Why?
That's just what cosine looks like. Cosine looks
Is
like.
this in the sound waves?
Huh?
When they say sine wave, is it the same thing? Like a sound wave? Like a triangle and a sine? Kind of-
Sound waves are different. They're all waves. This is a sine wave or a cosine wave. But pretty much, if somebody says a sine wave, they mean anything that looks like this.
So if it's x divided by 3, would that be 2 pi times 3?
X.
Cosine x divided by 3.
Yes.
So it'd be 6 pi. And tangent would be 2 pi over 2 pi. This tangent
Okay.
x would be 2 pi over 2 pi.
Tangent is different. Do you know what the tangent graph looks like?
I have to ask a question next, just to let everybody know, because there were like 4 or 5 questions from the same person.
Sure. Okay. You should start going to class more. What's the tangent of 0? What's the sine of 0? You should know this. Okay, well, here's a unit circle. Here's 0 on the unit circle. What's the sine of 0? Okay. What's the cosine of 0?
1.
Sine over cosine is tangent equals 0. So the tangent at 0 is 0. Tangent is positive in the first one. Yeah. This is kind of what tangent looks like. It's a whole lot of this kind of stuff. Wow, that's bad. It's a whole lot of things that come down in the class and go down.
Is it period pi?
Periods pi, yeah. The period is pi, yes. From here is 1 period. So then, if you wanted to find the period of tangent of 2x, what's the period of that? Oh,
Pi over
sorry, yeah, it's pi over 2. Okay, what's up, CJ?
Okay, I'm trying to evaluate 6 trigonometric functions here.
Did you get
on
sine
this
and
unit
cosine?
circle. It's the sine is the x value.
Sine is not the x
I
value.
meant to say this y value right here, and cosine is this
Uh-huh.
right here, these x values. So this is what I got. Since these are the points,
Yeah.
or the coordinates rather.
Yes.
These are the
Yes. Yes.
and then the tangent is just sine over cosine, right?
Yes. Yes.
One 56 over 65. Do I have to bring that down? There- This is negative, so it makes a positive number.
13 over 13.
Those get to cancel.
Yeah. Of course. You have, okay, so what this ends up being is you have negative 12 times 13 divided by 13 times 5.
Okay, so
You can just go ahead and drag the fraction line out and make it one fraction, and then just multiply the top and bottom. And now this should be obvious that you have 12 times 13 over 13 times something equals 13. That should be obvious.
that's 5 down at the bottom. Yeah.
Yes. So, yeah, well, now I'm giving you the answer, but that's okay. I don't mind.
Okay, so it's and those are positive. It becomes a positive number, right?
If the negative signs cancel.
Okay, and
I forgot my negative sign here. Yeah, negative signs cancel.
wait a minute.
Or my negative sign at the top, I don't know. There were two negative signs.
There was a negative sign. No, because it turns out to be negative 5 over 13, and then you flip it. See, it's negative, right? So negative.
It doesn't matter where
it doesn't turn out to be positive. That's what I'm saying. The number,
yes, it does.
the final number.
It does.
Then why is it negative there?
Because I left out the negative sign when I did it.
Oh, okay.
Yeah.
We're all happy.
Yes. I forgot to write my negative sign on the bottom.
And then just really on these ones, I got undefined, -1, -1.
What is 0 over anything?
0! 0 divided by any number is 0. Any number divided by 0 is undefined.
Yes.
Okay. I think the only thing I have left is this area.
Okay.
And I'll work on that fix. I'll have to figure out how this works. I just want to turn in number 9 before I leave today.
Okay.
You know, so this way you feel more comfortable.
Yes. So the practice test. How you doing? Good. All right. All right, guys. If no one objects, I'm going to move on
To identities.
The most important identity. It's the most important one. If there's any identity you learn for the exam, it should be this one. If there's any identity you learn from trigonometry in general, it should be this one. This is super, super important. Especially because if you have this, divide everything by cosine, and then your equal stays the same. Divide everything by sine, for example, you get sine squared over cosine squared plus cosine squared over cosine squared equals 1 over cosine squared. You can do things like that. You can get super useful expressions just by knowing this and how to manipulate it. I'm not going to write down the other things that you can do with it because there's too many of them. Instead, I'm going to write down the second and third, no, the ties for second most important identity. Sine of A plus B, cosine of A plus B. Everyone do that. Cosine A sine B plus cosine B sine A. This is super important. We need to know this for the exam. Hopefully this will help you too, Xavier. Does it help you at all?
Sort of. I already kind of knew that, like, I erased it because after that, multiply by these.
That's fine. And I distribute. I will bet. I'll bet. No, I won't bet you a case of beer. I don't know if you're of age.
I am not.
Okay. I will bet that if you expand this into that, then multiply by cosine, and then do the same thing to the next one, you'll get some sine squared plus cosine squareds flying around. Maybe times some things, but if you have sine squared plus cosine squared, you have this, which is the most important one. So yeah, just a lot of times the trick is make it look horrible, and then things will cancel out via that. This is usually the trick. When your answer looks horrendous, usually it's because you missed this, and your answer actually is pretty easy. It just you have one replaced with something garbage. So yeah, go for that. Go for it. See if that works.
So to use that to solve number 5.
Probably. Oh wow, yeah, 5 is easy. Yep.
Actually, are you feeling chilly in here? I'm feeling chilly in here, doesn't it? Okay, I wonder if the temperature is dropping outside. Okay, can I ask you, I remember you mentioning the other day, oh, this is going to take a long time. I don't know how much time we have. This graph, I can't figure out.
I don't have enough time to talk about that now.
Really?
Is that on the
Unless these two leave, and then I'd be happy to go over that. But
I'm just trying to
it's not
figure.
going to be
Can you
an
tell me
easy
just at least the first one how to do it, and then I can figure out the rest on my own?
one. This is a number in radians.
Radians.
Find out what quadrant 2 radians is.
Oh, okay. Is that really
Most people have a lot of trouble with that.
number?
Question?
number 5?
Oh yeah, number 5. Right. Read number 5.
Sine squared t plus cosine squared t over cotangent squared t plus 1.
this? What is this?
Is it 1? So isn't it beta?
No. Cosine squared, no, it can be anything. Sine squared of anything plus cosine squared of anything is 1. So, this is 1 over cotangent squared t. Let's think about this. Is there some way we can change this to have a cotangent somewhere?
Yeah, there is a way.
Divide
There's a
by
way.
what?
It's the cosine divided by sine. So I'm going
Okay, but you can't just divide cosine by sine. You have to divide everything by sine squared, right? Sine squared, not sine.
Yeah,
So yeah,
cosine squared divided by sine squared.
divide everything by sine squared. What's sine squared over sine squared?
1 plus cosine squared t divided by sine squared t
Which is cosine squared over sine squared
is the 1 over COT squared cotangent.
It's cotangent. It's cotangent.
T, cotangent squared t equals 1 over sine squared t.
What's this?
And that is, what is it? Not cosecant, but secant, right?
Cosecant.
Okay.
Secant is 1 over cosine.
Oh,
This is-
okay, so then it's cosecant squared t.
So we have 1 over cosecant squared t, which is
which is sine squared t. Sine squared t.
ta-da!
All of that just for this.
Welcome to trigonometry.
Okay.
It'll be even worse when you become.
Well, okay.
Yeah.
But you'll get paid more in the end, right? Okay, so you know how this is a number of radians, and then you said this is 2. Does that mean 1 radian is 180, correct?
Ooh, no.
Because it's pi.
No. 1 radian is 1. Pi radians is 100 degrees. Sorry, 180. I don't know what I'm talking about.
Yeah, I was
180
gonna say.
degrees.
1.
2 radians is a number of degrees. It is not easy to.
When it comes up to the 90 mark, how many radians is that? It is pi radian divided by 2.
Pi over 2.
Pi
radians.
over 2 radians is 90
Is
degrees.
pi over 2 bigger or smaller
Pi
than 2?
over 2 radians equals 90. Pardon, what was your question?
Is pi over 2 bigger or smaller than 2?
Smaller than 2?
Yes, smaller. Is pi bigger or smaller than 2?
Bigger.
So then 2 radians is in here somewhere. Now you can answer the question.
But how do I'm just guessing where the 2 was when you asked me those 2 last questions.
What's
You know,
pi
because I
over-
know that pi is the 3.1459,
Okay.
and that is 180 degrees.
Okay, you know this,
Yeah.
which means that you know this. 1.57 stuff.
Mm-hmm. Mm-hmm.
Bigger than 2, smaller than 2.
Right.
And you know that this is here.
So I don't
and
need
you
to know
that this
exactly
is
where
here.
2 falls,
It doesn't matter.
but I know that it falls in that quadrant, and so
Yes.
therefore I know that if it's the cosine, and cosine being the x value, it's going to be negative,
Okay, what about the sign?
and then the sign is going to be positive.
Yes.
Okay, so that's the
That's how you do it.
That wasn't really taking too long to. I didn't find that to be such a long thing.
Wait till you get to the last one.
What, the last one 6?
Everybody hated it. Everybody hated this one.
Okay, I'll do them all, and you'll say I get them all correct.
All right.
Can you do the second part? Okay.
Second part of it.
Right.
Secant squared t minus 1 over tangent squared. Secant squared t minus 1 over tangent squared t. Okay. Use the Pythagorean identity. Use that whole sine squared plus cosine squared thing.
Wait, I don't get it.
You don't get sine squared plus cosine squared equals 1.
What do you do with the 1? How do you...
So you start with this.
Right.
What did we do last time?
Didn't really follow.
What is secant?
1 over cosine.
Okay, so what if you divided all of this by cosine squared? Then you'd have 1 over cosine squared here, cosine squared over cosine squared here, sine squared over cosine squared here, right? Try that.
Okay, I got this graph done. How fast that look, or table rather. Tell me if you think that looks okay.
Okay, you're almost right. Almost.
I felt like I was just having a martial arts lesson right there. You know, Sensei never says that you're perfect, right?
Where's 11?
Okay, 3, 6, 9,
Pi, 2 pi,
2 pi, 3
3
pi.
pi.
Oh shit, I didn't go all the way almost all around to make it 12 pi. So it's probably in the 4th quadrant, I bet. So it's cosine is cosine is positive and sine is negative.
Where is 11? You think 11 is
I think it's in the
quadrant?
4th quadrant. I think it's between. Would you agree? No, you don't agree. So you think it's in the 3rd quadrant?
3 pi is less than 11. 4 pi is bigger than 11. Is 7 pi over 2 bigger or smaller than 11?
1, 2, 4, 6, 7.
So right now we know.
So that's in the 3rd quadrant is 7 pi 2. It goes up to the end of the 3rd quadrant.
But what? I don't know. Okay, so 11 is bigger than 3 pi, right?
Yeah,
11 is smaller than 4 pi.
right.
So it's somewhere in here, but we don't know where. So now we check this part. Is it bigger or smaller than this? Which is 7
Which
pi.
is 7
over
pi over 2.
And is it?
Okay, so I would have to do the calculation. So 7 times 3.1459 is like 21 divided by 2. 21 divided by 2 is 10.5 approximately.
approximately equal to, you said 21? Right?
Yeah, that's, and then divided by 2 is about 10.5. So,
So your guess is that 7 pi over 2 is bigger than 11? No,
less
smaller.
than, smaller. Smaller than 11.
That's what you think, right?
Yeah.
What quadrant would that put you in? That would put you in this quadrant, right?
Yeah. And I said third quadrant. Right? So is that where you agree with me then, that it's gonna, when I corrected myself, I said it's in the fourth quadrant, you agree with that, correct?
Yes.
Okay, so then the
It's very,
sin,
it's actually,
the cosine's positive and the sine of theta in this example would be negative.
it's actually very, very close.
Yeah, it's like just beyond,
Just barely past it.
just barely past it.
Because 0.14159
Starts to add up.
is a little bit smaller than 1/7. That's how I know this. That's why I thought this question was easy, because I know how big 1/7 is. Everybody else struggled with this question because
I remember doing.
Right, and when you have 1/7, and you have 7 of them, it almost adds up to 1.
yeah, right, exactly. So it's very, very close.
I don't know.
You don't know how to do it? Okay. Alright. Did you divide all of these by cosine?
Yeah, I got sine
Sine
squared t plus secant squared t equals 1 over cosine squared t.
Okay. You want to divide all of them by cosine.
Right.
Sine squared over cosine squared. Cosine squared over cosine squared. 1 over cosine squared.
Yes, I did.
So then you got sine squared over cosine squared, right? That's not what you just told me. But is this what you got for the first term?
I crossed out cosine squared and cosine squared. And got 1.
Alright, this is 1. That's right.
And I converted the 1 left to secant squared.
You turned this into secant squared.
But
What is secant?
4 over cosine.
What is sine over cosine? Tangent. So this is tangent squared plus 1 equals 1 over cosine.
Secant.
Secant. So then, secant squared minus 1. You subtract 1 from both sides here, right? Secant squared minus 1 equals tangent squared, right? By this, you subtract 1 from both sides. So what's the final answer? Sorry for anyone listening. I didn't realize that the thing was so close. One. Yes, 1.
But when we started, we weren't working with the equation, right? We were working with the formula. Because you had an equal cosine sine squared t plus cosine squared t equals 1.
Yes.
That's what we were working with.
Yes.
So, which conclusion are we drawing? The tan squared t or secant squared t minus 1? Like when we did
Simplify. It just says simplify.
This, I mean, but when we did this, we were working separate from the actual formula, right? And then we were keeping these conclusions back.
Yeah. We take the conclusion that secant squared t minus minus 1 is tangent squared t.
I'm giving you a love letter.
Quite an extensive
This, this is just a true statement. This thing we've written here is a true statement. It also happens to help us here. That's the whole point. We do something that we know is going to help us. Did you keep your thing?
I kept my practice exam.
And I have your other things.
Yeah.
Okay, cool. All right, you're good then. Bye. Thanks for coming.
I'm just gonna email the other TA really quick from CS 330, let him know I'm gonna show up about 3:15.
How long is this going for?
He says he's gonna be here till 3, and I'm gonna suck up every piece.
Can you go over 6?
What?
Can you go over 6?
Maybe what's 6?
Write a formula for the sine function with the amplitude, period, and phase shifts.
Oh, okay. Oh, you missed this. Okay. I guess that's how I would write that. Amplitude. Something of, oh, sorry. Something about changing your,
Phase shift,
nope, other one.
period.
Period, thank you. This is something about changing your period. This, I guess I should write it correctly. I should write it as a minus period. This is your phase shift.
Oh my gosh! The study abroad program to Stirling, Scotland has been moved. They moved the deadline to May 1st.
So you're gonna apply?
It was originally like March 17th or something, and I really wanted to take it. I think I'm gonna apply. I seriously wanted to go do it.
You should apply.
It's gonna be in Edinburgh, and there's gonna be like weekend day trips where you can like explore the countryside and go, like, you know, go to London for the weekend. You should do it with me, Martin.
How does this
Is
work?
that pi over?
Ah, damn, that like sounds so
Okay,
good.
so this is your phase shift. This B. This B is your phase shift.
Let's see.
T is T.
So keep that.
You have to, you always have sine of T. Sine is a function. You can't just have sine. It's not a wave if everything you have is numbers. You have to have some kind of variable.
You do 8.
Do what? 8. You try it. I'm giving you the important stuff. CJ,
Yeah.
any questions on the practice test?
Oh, I'm so excited. You don't even know. And I'm a big Scotophile too. I'm like so excited about this. Oh, I thought I missed it. Like God must have heard my prayer. Okay. Wow, that is like the best news I've heard. Okay. Oh, that's so awesome. Okay. Okay, so anyway, I'm sorry about that, guys. Practice exam. Let's see. I'm really grateful that he did this practice exam. This information here, by the way, I was just curious, are we going to be able to get that by email by chance, or just like go to the YouTube video and watch it?
Go to the YouTube video, because I won't actually have this.
Okay.
This goes to my boss, and he just uploads it all to YouTube.
Really? You think he's gonna do it in a timely fashion?
He'll probably get it done today.
What is the YouTube channel search on that, by the way? Is it CS or
IIT.
IIT and RC?
ARC. ARC.
Okay, IIT ARC. That's it?
That'll get you to our channel. Once you get to our channel, you'll have to look for Math 148 videos.
Search Math 148.
I don't know, Joe.
Okay, no problems.
Cool. Okay. What's the question? Sine of A plus B. Times cosine A.
The price has been okay, sorry.
Minus cosine A plus B.
Minus sine A. Okay, well, how do you start?
Or cosine A sine B plus cosine B sine A. But then you can multiply the whole thing by cosine A, so.
Yeah, of course.
Yeah, and then what do you do once you have it all spread out?
Probably things will cancel.
Can you, if it's all multiplied together, can you subtract?
We can probably do something. I don't know, I haven't done this question. I know how it probably should be done, but I've never actually done it.
Do you want me to read it out to you? It's right there. Can you just work through the problem?
Did you work through it?
Yeah, I didn't know what to do after that though. I'm trying to figure out how to cancel it out.
Okay, so we're going to multiply by cosine A, so I'm just going to do that now, if nobody objects. So we get cosine squared A, sine B, plus cosine B, cosine A, sine A, minus cosine, minus this part times sine, minus cosine A, cosine B, sine A, distribute by negative sign, plus sine A, so sine squared A, sine B. This should be very easy now. You must not have expanded correctly.
The final answer, cosine squared A sine B plus sine squared A sine B.
Did you just cancel the middle terms? Yeah, you cancel the middle terms. Cosine squared A sine B plus sine squared A sine B. Are you done? Okay, well, find out. Can you do anything else? What might you be able to do? Divide by sine B, okay. And then what? You mean factor sine B out, right?
Yeah. And then you can get 1.
Yes. You factor out sine B. You have cosine squared A plus sine squared A. Which is 1.
And can you just do 11 and 12?
11 and 12.
Yeah, this is the last one.
I think we went over all the problems today.
Okay.
I guess.
You tell me. I can cheat and give you the formulas again if you want.
Sine S cosine T minus cosine S sine T.
Sin S cosine T. Cosine S sine T. Yeah. S cosine, oops, cosine T minus cosine S sine T. Now, what are each of these pieces?
Contacting and emailing people, it's how it is. It's just never a break. I have to email people today for things that need to happen on Friday. I email people to let them know I'm still coming. Do you,
What do you know?
okay, it's like so exciting.
You know, secant equals 5/4.
You can apply for financial aid too. You should come with. Are you? You get college credit.
I will get my master's thesis.
Oh, that's what you're gonna work on over the summer?
Oh, no, I'm doing, yeah, well, yes, sir.
Mm-hmm.
What's 4 divided by 5?
4 divided by 5.
So would that be cosine be 4 over 5?
The cosine would be 4/5. Okay. So now we know cosine S equals 4/5. So what's sine S?
I don't know. How do you find it?
Found it. No, wait. Yeah, sure. Use this one.
So would that be 4 just squared? I mean like the input for cosine squared?
Whatever you have for the cosine.
No, it is squared.
Squared. Of course. It says cosine squared in the formula.
What's the square root of 1?
Square root of 1
So sine is 1/4.
is not 1.
It is.
Huh?
So sine is 1/4.
What?
1/4.
This is how you started, right? So then you plug in 4/5 for cosine. 1 equals 16/25.
You need 1/5. Forgot to subtract. It is square rooted. Is that okay?
What do you mean you just square rooted it?
And you need to get sine, not sine squared, right?
So what you're telling me is that you did square root of this equals cosine plus sine?
No, I had 4/5, and then
Why did you take the square root? Where did you take the square root?
I had 4/5 squared, and then I just subtracted that, so it's 1 minus 4/5 squared equals sine squared equals square root.
Okay, so you got 1 minus 4/5 squared.
Yeah,
And how did you take the square root of that?
it is square root of the whole thing.
How?
It is 2000.
So you just said this? 1 minus 4/5, is that what you did?
No, it should be 1 minus 16/25,
Why?
if anything.
Because that's what 4/5 squared is.
4/5 squared is,
It's sine squared. Don't you want it to be sine, not sine squared?
Yes, but you cannot take the square root of this. Sorry, I did that wrong. You cannot just take the square root of this and say that it's 1 minus 4/5.
Well,
Because that's not how square root works.
Sine square root of the sine squared. I did on
You
both
still
sides.
can't do that. That's like saying the square root of 3 minus 2 equals, oh shit, that's a bad example. That's actually true. Square root of 3 minus 1 equals 3 minus 1, which is not the case.
But you can't square root each part individually, like how you divide or multiply each part individually?
No, you cannot, no.
golly gee, my fingers are too big for this phone. Okay, I just emailed Dr. Zazi again, and I emailed him about the test on Friday, and I emailed him about activity 8 and 9 being given to you on Monday and Wednesday respectively, and that I'm still working on 10, and that I attended both of your sessions this week. And I didn't
Here it
copy
has activity 8.
Yeah, but I didn't copy you on that email because you don't need to know it, because you already know it. I plugged your email, right? I will casually reach out to you to see if you're, which means that, well, which means casually means no pressure. Reach out to you to see if it's convenient for you somehow, or maybe just like email you a quick question. If you're checking email, maybe you conveniently can get to me when you do. In that case, as you know, I've been running around since like 7:30 this morning. I might have to go to the CS 330 tutorial. Good luck, tutor. So see you guys.
Yes. Yeah. You get 9/25 is sine squared. So you get sine of s equals 3/5. 3/5. Okay, so now I have cosine S, you have sine S. I guess you probably want cosine T and sine T now, right? How can you do that? Cotangent T minus 1.
Tan is 1, does that make the cosine and sine both 1?
No, it makes the sine and the cosine equal. They can't both be 1.
So how do you not remember that?
Because there's only one place where they're equal. There's one obvious place where they're equal. So, cotangent is negative means that you're in which quadrant? No, because then you have here sine is negative, cosine is negative. So then this would be positive. So you're not in the third quadrant. In the first quadrant, both of them are positive, so you're not in the first quadrant. You're in one of these two. And you're given that T is between pi over 2 and pi. So you're not in this quadrant. So now you know you're here. There's only one place between pi over 2 and pi where cotangent T is negative 1, where the sine and the cosine are the same if you don't count this. The negative.
45 degrees.
Right here. What are the sine and cosine of 3 pi over 4? What you would call 135 degrees, I guess.
Square root 2
Are they both square root 2 over 2?
over 2? Yeah.
Neither one of them is negative?
Oh, the cosine is?
Now you have sine S, you have cosine T, you have cosine S, and you have sine T. So you just multiply and add, or multiply and subtract.
Okay, 8-ish.
So you can do this one, right? Can you do 12? I believe 12 is the same question, right? Oh, I guess you can do 11.
Yeah.
And 12 is easy. Factor. to factor that? Replace sine x with another variable. Call sine x y, something like that. Do you remember how to solve quadratic equations? Well, that'll be super important on the final, but on this exam, I guess it's okay. You can have the time. If you can't factor, use the quadratic formula.
Which ones are A, B, and C?
This is A, this is C. AX squared plus BX plus C equals 0. What is -2 on the bottom?
It is, sure. These say answers, or these just what sign equals?
Got 6/4. You just solved for sine x. These values are sine x.
How do I close the line if there's two answers?
Well, you can say that there are two answers. When you have a quadratic formula, when you have a quadratic equation, there's always two answers. Can the sine ever be 6/4?
What's the one, there's one in red for us.
It's not. It's 1 plus 5/4. It's 6.
The sign not be over one.
Hmm?
The sign not be over one.
Sine cannot be bigger than 1. So then, sine of x is
Is that the answer? Or am I supposed to put it in?
well, it seems right, but yeah, I would just put sine x equals -1 because I don't know what x satisfies that.
That's not what that's about. She worked it out. She would do it.
She factored?
And
Okay. So it's A is 2, B is -1, C is -3. B squared minus 4 times 2 times -3. Plus 4 times. Ah! Yeah, no, wait. Sorry. Oh, God. The 1 minus 5 is -4. -4/4, not -1/4.
I actually have to get the class.
Yeah, me too.
Thanks for the help.
Yeah.